Hello, we are the Wobble Board Force Quantification Team from the University of Rhode Island.
Of all the injuries athletes can obtain, ankle injuries are amongst the most persistent. It has been reported that an average of 7 in 1,000 individuals in the United States sustain an ankle injury on a yearly basis. With that being said, an important feature regarding these injuries is the rehabilitation process. One common tool that is used in a physical therapy environment in analyzing the recovery of these injuries is the Wobble Board. The patient can perform a variety of exercises given by a physical therapist and have the proprioception of their ankle tested. However, the Wobble Board currently lacks quantitative feedback and is a tool that only relies on visual observation, which may lead to an inaccurate assessment of the rehabilitation process. We wanted to address the question, can we quantify the amount of force a person is applying to a specific area of the Wobble Board? This led us to implementing an insole design that will be centralized on the Wobble Board, using force-sensing resistors as our pressure capturing device.
Our design has these force-sensing resistors embedded in between two insoles. Each force-sensing resistor is wired from the insole and soldered to leads that are electrically interfaced with our Arduino microcontroller on our breadboard.
With that being said, we needed to design a 3D printed stability ball that met requirements such as having the correct dimensions and depth to hold the breadboard, having 3 slits, 2 for exiting wires and 1 for the USB cable connection, and to have the ability to support the load applied when the Wobble Board is being used. The USB cable will be connected to the Arduino from the computer, powering all of our integrated force-sensing resistor circuitry. To connect our lead wires to the force-sensing resistors, we needed to make drill holes in the board for our wires to pass through.
With everything coming together, the insoles are attached to the middle of the board and are available for tests.
This is an idea of what we expect the exercises on our prototype to look like, as the patient is seated, having their foot placed on top of the insole, and isolating the ankle to the best of their ability.
As the patient is performing the exercises, the force data from each force-sensing resistor is collected, transferred into an output voltage, and digitally converted to a numerical output through the Arduino.
These numerical outputs are then transferred and manipulated into a heat pressure map that would mimic the foot. We believe that our product will have several benefits if used in clinical settings, which include cost-effective device, specific target users, and user-friendly. We believe that overall, our product could benefit our stakeholders, being physical therapists and ankle-injured patients, by providing analytical data to go along with visual observation. This would eventually improve the probability of a more accurate assessment to rehabilitation and therefore limiting the chances of recurring injuries.
Thank you for your time and consideration.